As with other welding processes, proper safety measures and equipment setup are an important part of gas tungsten arc welding, or GTAW, also known as TIG welding. Select each item to learn more. When using GTAW, remember to follow all general welding safety practices. Use protective clothing and equipment, such as a welding hood, flame-retardant clothing, and welding gloves. Take fire and explosion prevention measures, such as keeping a neat and clean workspace with no flammable materials nearby. Finally, be sure to use proper work area ventilation methods, such as this mobile-powered extraction system. GTAW also requires the use of some process-specific safety measures. The GTAW process generates significant ultraviolet light, which can result in an increase in ozone and nitrogen dioxide levels. Therefore, use additional ventilation measures or respirators. Because the UV radiation is often higher than other processes, welders should wear darker clothing, work in areas with reduced UV reflections, and take extra vision protecting measures. GTAW requires the use of cleaning solvents. Welders should carefully review the safety datasheet for cleaning agents to be aware of the flammability of the cleaning solvent in use as well as the storage requirements. Finally, the grinding of tungsten electrodes used for GTAW can result in tungsten dust and flying particles. Welders should take additional vision and respiratory protecting measures when engaging in the grinding process. Before any welding can occur, the welding area, the weld coupons, and the welding machine must be prepared. To prepare the welding area, ensure that the area is properly ventilated and free of any fire hazards. Locate the closest fire extinguisher. Make sure it is charged and confirm that you know how to use it if needed. Then, position welding curtains around the welding area. Once the work area has been prepared, it's time to prepare the practice weld coupons. Use a wire brush or grinder to remove any mill scale from the steel plate, since the direct current electrode negative used in GTAW has hardly any cleaning action. Finally, prepare the welding machine using the following steps. Step 1. Verify that the welding machine can be used for GTAW. Step 2. Find an air or water-cooled GTAW torch that is compatible with the machine and any cooling unit being used. Step 3. Locate the primary disconnect. Step 4. Configure the welding machine and torch for GTAW welding. Set the torch polarity. Equip the torch with a tungsten electrode of the correct diameter. Equip the torch with a proper type of filler metal for the application. Step 5. Connect the proper shielding gas for the application. Step 6. Connect the workpiece clamp to the table or workpiece. Step 7. Turn on the welding machine and follow the manufacturer's instructions for purging the torch. Step 8. Set the welding current in alignment with the desired GTAW application. GTAW weld bead characteristics and quality are impacted by the following factors: torch travel speed and arc length, torch angles, and handling techniques for the torch and filler metal. Select each button to learn more. Torch travel speed and arc length impact the GTAW weld puddle and penetration. Slower speeds create larger, deeper puddles. Faster speeds form smaller, shallower puddles. Increasing the torch height results in longer arc length, higher voltage, and wider bead width. The two torch angles that must be controlled during GTAW are the work angle and the travel angle. The torch work angle is an angle less than 90 degrees formed between a line perpendicular to the primary workpiece surface at the electrode contact point and a plane defined by the electrode axis and weld axis. In other words, It is the side-to-side angle in relation to the weld joint. The torch travel angle is an angle less than 90 degrees between the electrode axis and a line perpendicular to the weld axis at the electrode contact point, within a plane defined by the electrode axis and weld axis. GTAW uses a push angle where the torch is tilted back so the electrode points in the direction of weld progression. Push angles of 15 degrees to 20 degrees are commonly used to avoid drawing air and contaminating the weld. The two basic handling techniques used in GTAW are freehand and walking the cup. In the freehand technique, the torch electrode tip hovers just above the weld puddle, supported by the welder's hand, which may rest against the base metal to maintain the proper arc length. The torch tip can be moved in a small circular motion within the molten puddle to control its size, and filler metal is added as needed. The GTAW filler rod, held in the non-torch hand, is kept at a 20-degree angle above the base metal surface, aligned with the weld. Careful insertion of the filler metal into the weld puddle is crucial to avoid contaminating the tungsten electrode, which must be removed and cleaned if touched. Coordinating the electrode movement away from the weld puddle as the filler metal is added helps prevent contamination. In the walking the cup technique, the welder stabilizes the torch by resting the nozzle edge against the base metal or groove edges to maintain a constant arc length. The torch is rocked from side to side while advancing to control puddle size and heat both groove sides. Filler metal is added similarly to the freehand method, with caution to prevent electrode contamination. When welding with GTAW equipment, it's important to know how to create stringer beads, weave beads, weld restarts, weld terminations, and overlapping beads. Select each item to learn more. Stringer beads are produced with minimal or no side-to-side movement of the torch, typically not exceeding 3 times the diameter of the filler rod in use. Follow these steps for running flat position stringer beads. Step 1. Position the torch at a 15-degree to 20-degree push angle, aligning the electrode tip directly over the starting point of the weld. Step 2. Activate the electrode by pressing the remote control to initiate shielding gas flow. Step 3. Start the arc. Step 4. Move the electrode tip in a small circular motion until the weld puddle forms. Step 5. While employing either the freehand or walking the cup technique, slowly advance the torch and add filler metal as necessary. Step 6. Continue welding until a 2-inch to 6-inch long bead is formed. Then stop the arc without withdrawing the torch. Step 7. Maintain the torch in place for post-flow gas protection until the weld and filler metal cool sufficiently to prevent oxidation damage. Step 8. Remove the torch and, if remote control is unavailable, close the shielding gas valve. Step 9. Inspect the bead for straightness, a uniform rippled appearance, a smooth transition with complete penetration and fusion at the toes, a filled-in crater, and undercut less than 1/32 of an inch deep, or 10% of the base metal thickness. Also check that the bead has no overlap, pinholes, cracks, or excessive porosity. Welds are the 1F or flat position, the 2F or horizontal position, the 3F or vertical position, and the 4F or overhead position. Select. The open V-groove weld is a frequently used groove weld, typically applied to both plate and pipe surfaces. The root pass is the most challenging aspect of welding an open V-groove butt joint. It requires precise penetration without excessive melt-through or root reinforcement. To achieve this, it's crucial to utilize the appropriate amperage, filler metal application, and torch travel speed tailored to the specific root opening and root face. The desired root reinforcement should align with site specifications, ranging from flush to 1/8 inch. There are two methods for executing the root pass: the lay wire, also known as on the wire, and the keyhole technique. Regardless of the chosen method, it's essential to initiate the root pass from a tack weld. To execute the lay wire root pass technique, position the filler metal in the bottom of the V-groove's root opening parallel to the plates, and fuse it in place by moving the torch along the groove, using either the freehand or walking the cup technique. Ensure a steady advance, allowing thorough fusion without risking burn-through. This method is suitable for filler metals with a width that matches or slightly exceeds that of the root opening, similar to pipe welding with a consumable insert. It's essential to maintain a consistent bead thickness by avoiding unnecessary movement of the filler metal in and out of the weld puddle. To execute the keyhole root pass technique, angle the filler metal to the plate surfaces and introduce it into the groove root from the weld side. Utilize a filler metal rod with a diameter slightly larger than the root opening to allow the rod to rest on the groove. Groove welds can be made in a variety of positions. The 4 groove weld positions are flat or 1G, horizontal or 2G, vertical or 3G, and overhead or 4G. Select each button. When making a flat open V-groove weld, start by tack welding the weld coupon together. Then position the coupon in the flat position using a clamp or tack weld. Use an appropriate diameter of carbon steel filler metal to run the root pass with either the lay wire or the keyhole technique. A 15 to 20 degree push angle and a 20-degree filler metal angle should be used for pass 1. Clean the root pass. When using stringer beads, the remaining passes should be run using the same push angle and the appropriate work angles, as shown here. The filler metal should be held about 20 degrees above the plate surface. Remember to clean the weld after each pass. Weave bead passes will follow a different sequence, as shown here. Finish by inspecting the weld to ensure it meets acceptable criteria, such as a uniform rippled bead face appearance, restarts and craters filled to the full cross-section of the weld, uniform weld width, an acceptable weld profile, uniform and complete root reinforcement, a smooth, flat transition, and undercut within specifications. Also, ensure that there is no excessive porosity or cracks.